In this lesson, we're going to learn how to use logarithms and natural logarithms, ln, to undo base e and exponentiation to get variables in the exponent by itself. So the first example, here's actually our do now, and this doesn't require logarithms. Basically, we're just using, these are exponential functions. So we have a length L of a tiger shark. Depends on how old it is, t. So if a tiger shark is 3 years old, how long is it? Well, we use this formula right here. Plug it in. Carefully plug it into the calculator. Notice the use of parentheses around the exponents, the operations in the exponents. And our solution is 175.2 centimeters. Notice that this one is basically all the numbers are on the right, and we're trying to solve for L on the left. And our solution is simple. You plug it on the calculator. And I wanted to show you the difference between two different formulas. One formula is used for when you have regularly compounding interest. The other formula is when it's continuously compounding, okay? P e to the RT is when it's continuous compounding. When it's regularly compounding, for example, monthly would be 12 times a year, n would be 12, right? N is the number of times compounded per year. If it were quarterly, which is commonly used, quarterly means 4 times a year. Just think quarter, $4, 4 quarters in a dollar. So we had looked at this previously, this example here, where you have $1,000 at 6% interest in the bank for 5 years. So that means we're going to use this formula here, $1,000. 1 plus 0.06 to the 5th power. We plug everything into the calculator. We end up with $1,338.23. Now, part B, you don't really know how to do yet. This is new for the lesson. How long will it take for the account to double? So because we are doubling the amount of money, the principal is still $1,000. The interest rate is still 6%. And we're trying to find out how long it will take, so T is our question mark. Now, because we are doubling the money, A is now $2,000, because double 1,000 is 2,000. So our challenge is to get the T by itself, right? Previously, we knew what T was, we plugged it all in the calculator, and we basically got our amount after 5 years. But here we're working backwards. They're saying we have $2,000, this is what you want to end up with. How long is it going to take to get there? So we need to algebraically undo. We're going to divide both sides by 1,000 first. A 1,000 divided by 1,000 cancels out. 2,000 divided by 1,000 is 2, and we have 2 equals 1.06 t to the t power. Now, how do we isolate t? How do we undo exponentiation? Well, we use logarithm. So log of 2 equals log of 1.06, and this t comes down because of the property of logs. So we have log of 2 equals t log 1.06, divide both sides by log of 1.06. And what we put in the calculator, this cancels out. And what we put in the calculator is log of 2 divided by log of 1.06. And here's our answer, about 12 years. To solve for a variable exponent with any number base, apply log to both sides of the equation. You may recognize this one from a recent test that you really weren't ready for yet. So we're going to omit this problem from the test, not count it against you. In this example, you have bacteria in a petri dish, modeled by this function, where the number of bacteria is n, present in the petri dish after t hours. Using this model, determine to the nearest hundredth the number of hours it will take for n to reach 30,700. Ladies and gentlemen, this is an outbreak. 50 bacteria is now 30,700 bacteria. How long is it going to take? So we plug it into the formula. 30,700 goes into the formula. We're trying to find t. We divide both sides by 50. We end up with 614 equals e to the 3t power. Now, how do we undo an exponent with base e? You must use natural logarithm, ln. So we basically end up with ln of 614 equals 3t ln of e. Ln of e, since they are inverses, cancel each other out. Divide both sides by 3. Make sure when you put ln of 614 in the calculator, you close the parentheses before you divide by 3. Final answer is 2.14 hours. So the lesson is, to solve for a variable exponent with base e, apply ln to both sides of the equation. Save and scribe number 1. You have $5,000 in an account, 3% interest, compounded quarterly. The word quarterly tips me off that I'm going to use this formula with n, because n is 4. How long will it take for the balance to reach 6,000? Well, principal is 5,000, the amount we're reaching is 6,000, interest rate is 3%, quarterly is 4, and t is the question mark. So we plug everything into the formula, divide by 5,000, simplify 1 plus 0.03 over 4 to give me 1.0075, and then we take the logarithm of both sides. Log of 1.2 equals 4t log 1.0075. Since we want to get the t by itself, we're going to divide both sides by 4 log 1.0075. These cancel out, and now all we have to do is plug this in the calculator. And as you can see, we carefully plug this in the calculator. Make sure you after you hit the divide symbol, you open parentheses to group this expression down here below. Final answer is about 6.1 years. Last example, here's exponential decay. This is actually radioactive decay. 100 grams of radium are stored in the container. The amount R in grams of radium present after t years can be modeled by R equals 100 e to the negative 0.00043 t. After how many years will only 5 grams of radium be present? Ladies and gentlemen, that's why radioactive waste sticks around forever, because the half-life is so huge. So we're going to plug this into our formula to try to figure out how long it takes 100 grams of radium to decay down to 5 grams. So we divide both sides by 100. We're doing our algebraic isolation of t. You need to take the natural logarithm because we're dealing with base e. So we take the ln of both sides. As you can see, the exponent comes down. Ln of e cancels out. And our last step is divide both sides by negative 0.00043. Carefully placing in our calculator, our final answer is 6,966.8 years. That is a long time. Okay, ladies and gentlemen, there's your lesson on exponential growth and decay and using log and natural log to undo exponentiation. Best of luck to you.